So in the assignment, we have already discussed what is Pythagoras theorem, right? We have already discussed what is Pythagoras theorem. So given a right angle triangle ABC, say it is right angled at B, okay? Then the square of the hypotenuse is sum of the squares of remaining two sides. That is, AC square is AB square plus BC square. So this we have given in the assignment and we have asked you to prove it. Also, we have given you the hints how to prove it. So I think all of you might have done this. And the converse of this statement is also true, right? What is the converse of this statement? Say if in any triangle, okay, the square of one side is equal to sum of squares of other two sides. Okay, if in any triangle the square of one side is equal to sum of squares of other two sides, then the triangle is right angled. Okay, triangle is right angled. So this is the converse of the statement. This is also true. So I'll leave it as an exercise for you to do at home. Now let us discuss what are acute angled and obtuse angled theorems in a triangle. So first let us discuss what is an acute angled theorem. Okay. Say we are given an acute angle triangle ABC. Fine. So here the triangle is acute angle triangle. Now let us say you know the lengths of AB and BC, but you want to find out the length of AC. Okay. So what we do is here we drop a perpendicular from A to the side BC and say this point is D. So AC square is equal to AB square plus BC square minus twice of BD times BC. This is the theorem. This is the formula to find the side AC. Okay, so AC square is AB square plus BC square minus 2BD times BC. Okay, so just take a couple of minutes to prove this. You need to just apply the Pythagoras theorem. Take a couple of minutes and try to prove this. Okay, take a couple of minutes and try to prove this. You need to just use the Pythagoras theorem. Okay, so let us discuss this one. So in triangle ADC, let us apply the Pythagoras theorem because we want to find the length AC, right? We want to express the length of AC in terms of AB, BC, BD and BC. So I'm applying the Pythagoras theorem in triangle ADC. So I will get AC square is AD square plus DC square, right? So DC square, I can write it as BC minus BD whole square, right? So this is AD square plus BC square plus BD square minus 2 BC into BD. Okay. Now, if you observe AD square plus BD square, so AD square plus BD square would be AB square because ABD is a right angle triangle. So this will give us AB square plus BC square minus 2 BC times BD. Okay. So just note it down quickly, then we'll move further. Note down this formula, final formula, which we'll use later in problems. Okay. So let us talk about obtuse angle theorem now. In the previous case, the triangle ABC was acute angle triangle. What if the triangle ABC is obtuse angle triangle? Say this is the situation. So this is A, this is B, this is C. So the same thing what we do is we drop a perpendicular from A onto the side BC of the triangle. So let us say this point is D. Now you need to prove that AC square is AB square plus BC square plus 2 times BD times BC. So this you need to prove it. So just try this for a couple of minutes, then we'll discuss. And so let us discuss this one. So let us apply the Pythagoras theorem in triangle ADC, right? So this will give me AC square as AD square plus DC square, right? But what is DC? DC is nothing but DB plus BC. DC is DB plus BC. So this is DB plus BC whole square. So this is AD square plus BD square plus BC square plus 2 times BD times BC. Okay. But if you observe AD square plus BD square is nothing but AB square. So this is AB square plus BC square plus 2 times BD times BC. Okay. So this is the formula for AC square. So quickly note down the formula. Then we'll move further. So I hope you have already noted the formula. Now let us discuss one important point. See, if angle B in this triangle was 90 degrees, if angle B was 90 degrees, we have noticed that AC square is AB square plus BC square, right? If angle B was acute angle, then we have noticed that AC square is AB square plus BC square minus something, right? So I can say that AC square is less than AB square plus BC square, right? If angle B is acute angle. Okay. Similarly, you can notice that if angle B is obtuse angle, then AC square is AB square plus BC square plus something, right? So I can say that if AC square is greater than AB square plus BC square, then angle B is obtuse angle. Okay. Here we have proved that if angle B is obtuse, then AC square is definitely greater than AB square plus BC square. And the converse is also true. That is, if AC square is greater than AB square plus BC square, then the angle B is obtuse angle. And so the triangle will be obtuse angle triangle. Okay. So the conclusion is that if in a triangle, okay, if in a triangle, the sum of the square of any side, the square of any side is greater than the sum of squares of other two sides. Then the triangle is obtuse angle. Okay, then the triangle is obtuse angle triangle. So, and if it is less than this, okay, if it is less than, then this is acute angle triangle. Okay, and if it is equal to, then it is right angle triangle. Okay, so you need to tell me whether the triangle is obtuse angled or right angled or acute angle. So the sides are 3, 4 and 6. So just tell me whether the triangle is obtuse or acute or right angle.
9.
So you need to tell me whether the triangle is acute angled or the triangle is obtuse angle triangle or right angled. Okay. So here we can see that 6 square is greater than 3 square plus 4 square. So this implies that triangle is obtuse angle triangle. Okay. So now let us discuss the Apollonius theorem. Okay. Apollonius theorem in a triangle. So what is the use of Apollonius theorem is that if you are given all the 3 sides of triangle ABC, okay, so you are given all the 3 side lengths, that is AB, BC and AC, and if I ask you to find out this length AD, where AD is the median, okay, then Apollonius theorem comes to our help. Okay, so the formula is AB square plus AC square is twice of AD square plus BD square. So since you know AB, AC, and since you know BC, you know BD, right? It is half of BC. then you can find out AD. So just try to prove this one using acute and obtuse angle theorems, then we'll discuss. So first drop a perpendicular and now you try to prove this one. Fine, so let us discuss this one. So we have AB square here and AC square here. Okay, so to get AB square, we can use this acute angle triangle ABD, right? So from this triangle, I can write AB square as AD square plus DB square minus 2 DM into DB. Okay, so AB square is AD square plus BD square minus 2 DM times DB. Similarly, to write AC square, I'm using this triangle ADC. This is obtuse angle triangle. So AC square is AD square plus DC square minus 2 MD times minus 2 DM times DC. So AC square is equal to AD square plus DC square minus 2 DM times DC. Okay, now let us just add these two equations. Okay, so if we add these two equations, I would get AB square plus AC square is twice of AD square plus this BD and DC are equal, right? Because AD is the median. So BD square plus DC square, I am writing it as twice of BD square. And BD and DC are also equal because this is AD is median. So minus 2 DM DB. Okay, just a second. I think here it should be plus, right? Because this is an obtuse angle triangle. So triangle ACD is an obtuse angle triangle. So AC square is AD square plus DC square plus 2 DM times DC. So this is plus 2 DM times DC. So if we add this, then these two gets cancelled. That is minus 2 DM DB and plus 2 DM DC gets cancelled. So we will be left with AB square plus AC square is twice of AD square plus BD square. Okay. So now you can find the length of median AD. Similarly, you can use this theorem to find out the length of medians BE and CF. Okay. Fine. So now just a small question. Say we have the length of sides of triangles as 4 and 9, and the length of median drawn to third side is 6. Okay. So this is length of median drawn to third side. So you need to find out the length of third side. So these are two side lengths. Say AB is given as 4, AC is given as 9, and the length of median is also given to you as 6. So you need to find BC. Okay, so try this one, then we'll discuss. So if you get the answer, then let me know it in the chat. Okay, so let us discuss. So I have got 5 different answers from 5 different students. So let us see which one is correct. So let us use the Apollonius theorem, that is AB square plus AC square is twice of AD square plus BD square. So 4 square plus 9 square is twice of 6 square plus PD square. So 9 square is 81 and 4 square is 16. So this is 97, right? Over 2 minus 36 is PD square. So then BD square is 97 minus 72, which is 25 over 2. So this implies that BD is nothing but 5 over square root of 2. So BC is 5 times square root of 2. Okay, so this is the correct answer. So I think all of you have got different answers. So just copy this, then we'll proceed further. Okay, let us move further. So in this question, it is given that two sides of a triangle are root 3 and root 2. Okay. It is also given that medians to these two sides are perpendicular. Medians to these two sides are mutually perpendicular. So you need to find the length of third side. So two sides of a triangle are given, root 3 and root 2. It is given that medians are perpendicular. You need to find the length of third side. So just try this problem, then we'll discuss. First, draw the diagram. So if you get the answer, you can tell me in the chat. Okay, let us discuss this problem. So AB is root 3, AC is root 2, and it is given that medians are perpendicular. You need to find out the length of BC, right? So if AB is root 3, then BF is root 3 over 2, and CE is root 2 over 2, right? So this is 1 over root 2. Okay. So let us say the medians intersected centroid G, right? And the centroid divides each median in the ratio 2:1. So let us say the length of GE is X. So the length of BG would be 2X, right? Similarly, the length of GF be Y. So the length of CG would be 2Y. Okay, so we have used the property that centroid divides the median in the ratio 2:1. Now, let us use the Pythagoras theorem because we know that the medians are perpendicular, right? So let us use the Pythagoras theorem in this triangle FGB and GEC. So if you use in the triangle FGB, you will get x 2x whole square plus y square is equals to root 3 by 2 whole square, right? That is 4x square plus y square is 3 over 4. Similarly, if you use the Pythagoras theorem in this triangle GEC, you will get x square plus 4y square is equals to 1 over 2. Now we want the length of BC, right? What is BC? BC is nothing but 4x square plus 4y square. That is BG plus BG square plus GC square. So let us add these two equations. On adding, I will get 5 of x square plus y square as 5 by 4, right? So then 4 into x square plus y square would be 1. But 4x square plus 4y square is nothing but BC square, right? So BC square is 1. So then I'll get BC is equals to 1 unit. Okay. So just copy it down, then we'll move further. Copy this down quickly, then we'll move further. Okay. So let us move further. Now let us try to see what is Stewart's theorem. So say you are given a triangle ABC and say you know the length of AB, AC and BC, right? You know what is AB, you know what is AC, you know what is the length of BC. Now, if you want to find out the length of AD where AD is the median, then you can directly use the Apollonius theorem. Let us say D is any point on BC. Fine. D is any point on BC. Okay. If D is any point on BC such that the length of BD is say M and the length of DC is say N. Okay, this is the thing. And now you want to find out the length of AD. Okay, AD is not perpendicular. Okay, so it might be appearing perpendicular in the diagram. Just a second. Let us say this is D and this is AD. So you want to find out the length of AD. Right? So you know all the lengths AB, AC, BD, DC. Now you want to find out the length of AD. So for this purpose, we use this Stewart's theorem. So the length of BD is M, DC is n. This is B, right? The length of AC is B, the length of AB is C, and the length of BC is small a, right? So the formula for Stewart's theorem is A into D square plus Mn, where this D is the length of AD. A into D square plus Mn is B square M plus C square N. Fine. So A into D square plus Mn is B square into M plus C square into N. So this is the formula. So just copy the formula, then we'll see how to prove it. Just copy the formula quickly, then we'll see how to prove it. Okay, so now let us see how will we prove this thing. So let us just draw the figure again. So this is our triangle ABC and this is our AD. Okay, so what I'm doing is I'm dropping a perpendicular from A onto side BC. So let's say this is point M. So now again I'll use the acute angle theorems and obtuse angle triangle theorems. So how do we write the length of AB square? Right, AB square is AD square plus DB square minus 2 DM times DB. Fine. So AB square, which is nothing but C square, is AD square, which is D square plus BD square. BD is equals to M, right? So first let us write it in terms of AB. AB square is AD square plus BD square minus 2 times DM times DB. So this is C square is equals to D square plus M square minus 2 DM. Let DM be X. Okay, so this is X, BD is M, and DC is N. So minus 2 into X into DB is M. Okay, so this is the first equation. Now let us use the theorem for triangle ADC. This is the obtuse angle triangle. So I can write AC square as AD square plus DC square plus 2 DM times DC by obtuse angle triangle theorem. So AC square is nothing but B square is equals to D square plus N square plus 2 into X into N. Okay. So now if you see these two equations, okay, if you see these two equations, so we want B, we want C, we want D, we want M in the formula, we want N in the formula. This X is unwanted. Okay, so this X is unwanted in these two equations. So you can see that in the formula there is no X, right? This is our assumption. We have drawn a perpendicular AM and we have assumed the length of MD as X. So our aim is to eliminate this value of X. So how will we eliminate this X from these two equations? Let us say this is equation number 1 and this is equation number 2. Okay. So you need to eliminate the value of X. So simple way to eliminate X is, let us multiply equation 1 by N and let us multiply equation 2 by M and let us add these two equations, right? If I multiply this equation by N, I'll get 2mxn here. And if I multiply this equation by M, I'll get 2x and M. So if I add those two things will get cancelled. Okay, so that's what I'm doing here. So multiplying equation 1 with N plus multiplying equation 2 with M. So this will give me N times C square plus M times B square is equal to D square times of M plus N, right? Plus M square N minus 2x Mn plus N square M plus 2x Mn. So I've just written the values by multiplying first equation with N and second equation with M. So these two things gets cancelled, and we have here b square m plus c square n is equal to d square into m plus n. What is m plus n? M plus n is nothing but a plus, from these two terms, that is m square n plus n square m, I can take mn common and I would get m plus n. So again m plus n is equal to a. So m plus n is equals to a. So now let us take a common. So I have d square plus mn is b square m plus c square n. So this is the final formula which I want for the Stewart's theorem. Okay. So here what we did, we just dropped the perpendicular AM, and this MD we have assumed it to be X. So we wrote the theorems using acute angle triangle theorem and obtuse angle triangle theorem. And finally we just eliminated X and we got the formula. Okay. So just copy it down, then we'll move further. So quickly copy it down. Fine. So let us move further. So let us see this question. There is a triangle ABC and it is given that the internal angle bisector of angle A meets this side BC at point P, and it is given that B is equals to 2C. So you need to find out the value of 9 times AP square plus 2A square over C square. Okay, what do you mean by this small b, small c and small a? So this side which is opposite to vertex B, that is AC, is denoted by small b. The side opposite to vertex C is small c, and the side opposite to vertex A is small a. Fine. So AP is the angle bisector of the angle A. You need to find 9 AP square plus 2A square by C square. So try this problem, then we'll discuss. Okay, if you get the answer, then you can tell me in the chat. So you need to use the Stewart's theorem and the internal angle bisector theorem, which we have learned yesterday. So the answer is integer. Okay, it is not in terms of A, B, and C. It is just a number. Fine. So let us discuss this one. So it is given that B is equals to 2C, right? And we know that since AP is the angle bisector of angle A, we know that BP by BC is AB by AC, right? That is the internal angle bisector theorem. So BP by BC is AB by AC, which is C over 2C, which is 1 over 2. So this ratio is 1:2. So then the length of BP is A by 3 and the length of PC is 2A by 3. Fine. Now let us use the Stewart's theorem, right? Because in this triangle we know AB, we know AC, we know BC, we know BP, we know PC. We want to find the length of AP. So let us use the Stewart theorem. So according to Stewart theorem, BP is M. So M is A by 3 here and N is 2A by 3. So A into D square plus Mn is D square M plus C square N. This is the Stewart's theorem. So A into D is AP here and the value of M is A by 3. The value of N is 2A over 3. This is equal to B square. Instead of B square, I can write it as 4C square because B is 2C. 4c square into the value of m is a by 3 plus c square into the value of n is 2a by 3. Fine. So let us cancel a on both sides of the equation. Then we will get ap square plus 2a square by 9 is equals to c square is common, and this is 4 by 3 plus 2 by 3. So this is 2c square. So now let us just multiply 9. 9 ap square plus 2a square is 18 c square. So 9 ap square plus 2a square by c square is 18. Okay. So first I have used the internal angle bisector theorem, that if AP is the angle bisector, then BP by PC is the ratio of its sides, that is AB over AC. Then I got the length of BP and I got the length of PC. Then I use the Stewart's theorem. Okay, so just copy it down. Copy it down quickly. Fine. So we'll end this session here, and I will send you the assignment in the group. And if you have any questions,